see Rick is here. Hey, if you have anything you want to talk particularly about Eve, I know that there was a request for a PDF of the article that we wrote about the link budget. I think that's still outstanding. That was over the past week. I think DSES asked for a PDF version of the
Yeah,
article.
yes.
Yeah, I have not done that yet, but I'm still catching up after the trip. So if
Um,
that's still of interest, then I'll get to it as soon as I possibly can. And then is there anything else that we can do?
um, I've, well, on this particular project, I've been working on a Visio diagram that Alex provided. That is a proposal for the next generation antenna feed, and it's quite complicated, but not that not that complicated to build. Just the block diagram of he wants to put everything needed for the science modules and the ham radio modules into one electronics package with with an SDR that can do up to 6 gigahertz and would deliver all the results down to the ground on fiber optics, which we already have installed. It's an interesting proposal. I spent a lot of time the last couple of days modifying it, and I'm about to send it back to Alex for to say, no, we really need all this other stuff to make it even more complicated if you're going to do that. But one
And
page of
people that
that,
are for people that are following along, when you talk about the dish and the site, what you're talking about is the, the 18-meter dish at Deep Space Exploration Society. So this is a significant, a large dish for citizen science, amateur radio, amateur astronomy use. So, the package that you're talking about would go uh, for that particular site.
yes, it would go inside the feed, um, just behind the antenna itself, or the antenna itself. But page 3 of his Visio file is sort of an interesting page. I'm not going to modify it. He has a link budget here, which I believe needs work. It is the link budget for Voyager 1. And at a recent engineering meeting, we discussed Voyager 1 and 2 with our European partners, and they showed us their results, which were quite astounding. They were capturing the signal at quite a few dB above the noise with only integration times of 1 minute. Well, this link budget of Alex's suggests the uh, signal to noise is minus 2.3 dB. I think that might be a little off, but in any case, we might want to do a link budget for Voyager spacecraft. We're giving serious consideration to putting up a package to receive those signals. All evidence is a dish our size should have no trouble with that. The problem I have is that our SDRs are all limited to 6 gigahertz, which means we'll need some sort of additional front end, and that front end needs to be synchronized to our reference uh, oscillator. So it's going to be a tricky design, but I think that's the next the next path that we want to analyze, and it should be a lot of fun and simpler They said they were receiving the signal almost 10 dB stronger than the Venus reflection. So this should be a fun project that we can enjoy and just receive the signals as soon as we figure out the 8 gigahertz down converter that has to be properly synced.
Yeah.
But it's just one of dozens of new applications that are popping up for a dish this size. Uh, I'd like to transmit opulent voice and bounce it off the moon. We don't have a satellite, so we might as well use the moon. What the heck? Uh, it's our signals are very strong, so you can probably put a small dish in your backyard and receive our signals because they're very, very strong. When you transmit 1500 watts into an 18-meter dish, the moon is easy.
I know that there was some discussion to set up maybe some plans for Earth, Venus, Earth for 2026. So
Oh, we're definitely going in that direction. That one will be on 2.4 gigahertz. We're almost certain of that. We don't know how to create that much power on 2.4 gigahertz. The current suggestion is a battery of 200-watt amplifiers, all merged together, and that's going to be right now. That's just what we did on 1296 on steroids because we only combined two amplifiers. We're going to have to combine quite a few amplifiers to make 1500 watts at that rate,
so is
or
that
redesign from scratch.
is the goal 1500 watts or I
Oh,
mean
yes. Yeah.
I would
1500 watts, key down, 100% duty cycle for 4 minutes at least.
yeah, I think that's probably a better place to start than a whole bunch of smaller amplifiers that would reduce the risk. I mean DB there may be there's a DB6NT that comes close.
We were hoping, but not so much at that frequency. Uh, Too many people um, are in trouble when they transmit any power at all on that frequency because it shuts down all the Wi-Fi within miles. But if we shut down all the Wi-Fi within miles, we're shutting down nothing.
Right. I think this is your site is interesting because yeah, that's one of the things that you have less to worry about. It's just the Wi-Fi that you happen to have around at the site might be there's ways to get away from that, you know. We've
Yeah.
seen this at other sites, other similar sites, and the mitigations that they take, you know. But I know there's an off catalog part from DB6 and T that might be of interest, and there are some other there are some other designs out there. This is more than
Well,
a
I
design something
I
for
was just checking to see how much trouble we're in. Uh, when we do this high power at 2400 megahertz, the closest big city to the dish uh, is 3 miles away, and that's as the crow flies and as the car drives, because out here roads are straight as an arrow.
yeah,
Uh, and that city is Haswell, Colorado. And I just looked it up on Wikipedia. It has a population of 71.
yeah,
So I think we can negotiate with them over their Wi-Fi. The next nearest city is 30 or 40 miles away.
yeah. Okay. No, we got time. We have time, and I think if we approach it sort of in a sort of systematic way and work through all the issues that not just the power but also the cleanliness of the signal can be addressed. And if there is
Yes.
any sort of experimental license, if we have to, you know, ask for some sort of variance, then we have plenty of time to do that. And in the past, that's been obtainable. So, you know, worst case, even if we say, oh, you know, it looks like it's pretty likely, you know, because for dishes, like the lobes of the dishes, the spillover and stuff is at least for the smaller dishes, it's only 40 dB down. So if you're talking about large power, then it's a significant amount that goes out. We can model that and look at it. And if we do think that there's going to be some sort of problem, then we have enough time to work it through. I think 1500 watts would be the goal. This is a hell of a path loss, and it's a different
Well, we
path. And
we're
I mean, we
we're
want to move
trying to,
from like carrier wave and just bouncing a radar signal. We want to move to actual communications, and that's going to require more link. We just
yeah,
simply need to have, more traction there. So anything that we can do to make this possible, I think we
well,
should.
it gives us a lot more gain
Yeah,
from the antenna, that is a narrower beam width. So we throw away less power when we do hit Venus.
right.
And
And
we
it's
will,
better. The 20 about 2.4 gig is ideal. That's where all the 1960s radar bounce stuff was done at. So
well,
that's
it turns out that if you keep going up, hoping to get a narrower beam, it doesn't work
right.
because the reflectivity of Venus falls off above 2.4 gigahertz for reasons that I don't yet understand. But that was a fairly recent discovery.
Yeah, yeah. No, it doesn't. It's not great. Not great hire. So yeah, I'm looking forward to this. So I owe the a PDF of the write-up. We have a lot more information to put in it too. Um, so Pete is working on a delay Doppler channel, protocol. So he's working on to construct a message, to construct a signal using delay Doppler techniques, very similar to OFDM. Uh, and then that's a article that he's well on the way to getting finished. So it's out for review, and we've looked at it and given some feedback. There's also another really nice batch of work from Dr. Estefes from Spain. So Daniel Estefes is a long time collaborator, and he took the CAMRAS or the Dwingaloo Stockart data and analyzed it and looked at it. And he's got a ton of good stuff that he's published on his blog, and we're also going to incorporate that into the link budget into the description. So the article that we have that went out in March, it's going to get a substantial revision for April, and we'll just keep sending copies of it. Whatever the current when we say the article, it's like what we're doing is taking our Jupyter Lab notebook for the link budget for this project and incorporating, like adding a lot of text. So it is a very heavily described link budget. So I think it's up to nearly 100 pages if you had to print it out. Um, and what we want to do is make it as accessible and relatable as possible to anybody interested in this sort of work, to try to bring you from, oh, I'm interested and I have some technical background as an amateur radio operator, and then get you educated about all of the different digital signal processing things that are required for a link of this challenge. So, when we talk about Earth, Venus, Earth, this is a very challenging link. Earth, Moon, Earth is a very challenging link, and Venus is a whole lot further away. So, and also
Yeah.
rotating. So it has that Doppler spread thing is a big deal. The recent work from Dr. Estefes directly addresses Doppler spread, and the news is good. He explains why it's not as bad as our physical model would suggest. So there's reasons
Oh, good.
that it's not quite as bad, which we've talked about a couple of times, that the edges of Venus don't contribute as much as you would expect, and that the atmosphere, although the atmosphere actually does kind of mess things up for you. Um, and this is something that Bockham, that the AMSAT DL folks found as well. They saw this too. They had a less than expected Doppler spread. Thomas brought this up a couple of times in our meetings. So that's what we're going to incorporate. We're going to look at everything that Dr. Stefaz has done and everything that Pete has done and put that into the document as well. Um, so I think I'll there was a call to like talk for a meeting to talk about the October 2026. That's the next opportunity for this, because that's the next inferior conjunction between the Earth and Venus, meaning they're closest together all on this side of the sun. Um, and so, hey, this past March 22nd, 2025, 25 being that was the inferior conjunction, most recent one in the past, and all of the stuff that we learned and all of the things that happened. Now we have, almost 18 months to prepare for the next one, and a big international effort will achieve some amazing things. So moving it from just simply being able to detect a carrier wave to actually being able to demodulate communications, having information be sent. That's kind of the goal, and it's a difficult one. So we're right
Yes.
on the edge of that, I think, with some of the updated Doppler spread models and the delay Doppler channels. I think like Zadov-Chu style, but even further pressing out the edges and getting more information into the signal. That's going to be the way to do it. That is looking very, very likely. So we'll be able to publish more and propose and the goal here for like once you construct the signal, once you define it and publish it and describe it and teach people, because delay Doppler channels are not as widely known as some other type of channels. Just describe this and then to publish files. So here is a SIGMF file that gives you, here's the IQ, values that you're going to send. Here's the metadata that describes like at what frequency and all the rest of that stuff. And so here you go. Here's your file that you can send, and that opens it up to a much larger number of participants than just forcing people to kind of recreate it from a text description or an academic description. So the goal is to provide files, to publish files of like try this, send this using this metadata using these settings, with your SDR, and then wait 4 minutes, and then
Yeah,
and then
that's
also like
that's assuming you want to hear your own signal. If
yes,
you
or
if you don't
tell
mind
your
not
tell the
hearing
other
it,
receivers, here you
you
wait 4 minutes for it to go round trip, and then oh by the way, here's how you integrate these recordings. Like listen,
know,
record, you know, make a digital recording of your receiver. Look very
well,
carefully, correct for a
that's
Doppler.
where
You know.
that's where I have begun, just barely begun work on a new project, which relates both to EVE and our science projects, pulsars, magnetars, so forth. Um, and that is, I recognized that the Europeans heard their, well, they only transmitted on one of their two sites, but both sites heard the reflections. And of course, they burned up their amplifier in the process, but so, and we didn't, but that was good for us, but not good for us as nobody heard our signal. So I began looking at what they were doing to receive. And what they're doing to receive is closer to what I'm used to seeing in the commercial VLBI world, which also is looking at pulsars. Um, and they have taken a classical design and optimized it for uh, their use in amateur, if you will, grade. Their dishes are quite large, so it's just barely amateur. But by using by taking a set of software and hardware tools and putting them all on a local area network with at least a gigabit of bandwidth, uh, they have created a set of tools based on uh, taking the raw data from the telescope and converting it to IQ data, which is a problem because it creates huge files. Uh, but some of their tools work in real time on that data as it's being pumped into these files. And some are post-processing, as you might suspect. Uh, and their methodology is very similar to ours, at least our science package, but with totally different tool concepts. Some of the tools uh, they have made themselves, and they're in a variety of languages, mostly C, C++, and Python, depending upon what you need. And they call it, the center of it is called VRT, which is Vita 49 Radio Transport. And so I'm working with Roger, one of our other deep space team members, to put together one or more virtual machines that will contain all of the software tools that they're using at Dwingelo, uh, including the hardware. We have a couple of B210s for the front end, and and they have a stack of tools. And what they want me to do is compile them from source, and they're all on GitHub, and they're all open source. Anyone can play with them. And they want me to compile them into any Linux environment I choose. They say they're not picky. They didn't create the tools for a specific environment. So we'll see how that goes. And at the same time, uh, the their other team member, Tamojan, he sent me um, a script file for building, what do you call it? I forgot the name of it now. It's it's a different environment for building all these tools. And in fact, the tools come in binary with all the libraries and everything. Um, and so I'm also going down that path. That's a slightly different than building virtual machines, but we're going to eventually have one or more computers. These tools are set up so they're networked. They don't care whether they're on the same computer or on different computers. Some of the tools don't care if they're remote. They can be at your house. Um, and so I'm very anxious to see how this all plays. What I'm planning on doing is going down with Dan on when we do pulsar work over the summer, um, and tapping into the same RF feed at the same time that Dan is gathering data in his traditional tool set. I'll gather it in this IQ tool set, and we'll compare notes as we try to analyze the data both in real time and offline and see what happens. The end result will impact how we architect the EVE project. We have 18 months or less to do that. So this affects both environments. And we may learn that, well, we don't know what we're going to learn. And I'm very excited about that because when I know so little, uh, and there's so much to learn, and these two telescopes in Europe already have a lot of background in this, so they can teach me. That's that's where the fun is. So we'll see how that goes.
Okay. No, looking
And
forward
we can practice. We're going to practice with Dwingelo by taking milliwatt signals at 1296 and bouncing them off the moon to get reflections that are about as strong as the Venus reflections were to see how well we do.
to.
We
Okay.
won't have the same, a lot of things will be different, the Doppler spreading and all that, but at least we'll be able to do some practice runs, see what's right.
Yeah, I think that was our same thinking laid out in the article was, in the meantime, to put together some digital signal processing and some protocol files and then bounce them off the moon, and that would that would give us a lot to work with. It's not a, like you said, it's not a perfect model. I think that's kind of what we say is, so you don't have the Doppler spread, but we have a good model for that. Um, and it's more accessible. So even though it's still a pretty rare part of the hobby, it's a whole heck of a lot easier to build up an EME station than to go find an EVE station. So
Well, if we use the same hardware that we used for EVE, except turn the power down,
yeah, yeah,
well,
it gets you close. So you're able to
we
crack
we
the code.
can we can have you paste into your model uh, a milliwatt off the moon has Doppler spread, has raw Doppler, it has all those things. They're just different. Um, we could do another model to verify that our experiments are at least worth pursuing
Yeah,
during this 18 months period. And it wouldn't be much different than the model you already did. So that would be fun.
yeah, no, we'll
Hi.
just keep at it.
Hi, this is Adrian. I have a question.
Sure, go ahead.
Um, sure. This is in regards to your requirements for the 1500 watts at 2.4 gigahertz. And I'm just curious, didn't the initial EVE accomplishment um by the European group utilize a actual CW operated frequency stabilized magnetron
Yes,
for their initial for the initial EVE accomplishment. So I was just
yes.
curious, why not replicate that? It seems like that would be a
Oh,
real easy way to get
there's a couple of reasons.
1500 and more.
Couple of
Uh,
reasons why we don't replicate that. One is it was 5 or 6 kilowatts, way above the legal limit. And one of our goals is to stay within the ham radio legal limit. Second reason is a magnetron is very difficult to modulate with intelligence. It's really good for radar, which is what they did.
right.
But our goal is not to duplicate what they did. We already did that in the sense that the European telescopes heard their own transmission. Uh, our goal is to transmit human intelligence, whether it be Morse code or some other encoding system, no matter
Well,
how slow it is.
but
Our goal was to transmit a message.
right. But
And
weren't
it's
they
hard to
able?
do with magnetron.
But weren't they able to actually utilize the frequency stabilization? And I understand that you can operate the magnetron in a CW mode, continuous wave mode, in the what is it, backward emission, where the filament gets turned off, and by frequency injection stabilization and being able to lock a stable operation, they were actually able to uh, able to even transmit single sideband potentially in that mode. I realize it's a very difficult process of trying to stabilize a magnetron and trying to stabilize it on a frequency and then modulate it. But for sure, frequency modulation would not be the optimal, obviously, but that would be easy for sure. And and by stabilizing the magnetron to such an extent to make it to make it a more linear amplifier, then that they were able to achieve stability sufficient and modulation for even for single sideband. At least this is what I understand from reading their original reports. So I was just curious. A simple microwave kitchen magnetron will provide nearly a kilowatt. You don't need a specialized 6 kilowatt magnetron. You might even be able to parallel two magnetrons and get close to your 1600 or 1500 watts of needed power emission. I was just curious if that even was even thought of in terms of possibly
Well, we
rather than a
didn't,
solid state transmitter, which would be,
uh,
as you said, so
we,
problematical in getting that much power at that
sure,
frequency.
we did not have that issue on this previous test because we're running at 1296 where we
Right, right.
had relatively easy access to power. we just put two 1200-watt amplifiers together. And that gave us, and they were not, designed for 100% duty cycles. So we ran them light, combined them, got 1500 watts that we could leave on for 4 minutes, and it was fine. But this came up only when we went looking and couldn't find an easy source of high power at 2400. So you're right. We got to consider all possibilities as we move forward. So the project has a number of areas where people can contribute their ideas. I recommend you go to dses.science and look at our website and consider joining.
I've actually joined DSES, so
Oh, have you joined? Good.
I'm actually a member. Yes, not a very long time member. I've just recently joined in the last couple of months, but
Well, the next
but
thing
I
you
have
need,
kept up with the work that you guys are doing in the
the next
EV.
thing you
So
need to do is come visit us on the site.
it's a bit of a trip. I'm down in San Diego, same as Michelle here, so it's a bit of a drive. So,
Kind of a long
but
commute for us.
Well,
I'd like to do it at some point. It's just
it turns out that there's there are flights from there to here that cost less than the
oh
gasoline.
God, I have a private pilot's license, but I would not get on a commercial airline to go anywhere.
Oh,
And
well,
I don't really want to fly myself in any place like that either. I'm actually not flying anymore because my eyes have kind of deteriorated to
oh,
the point
yeah,
where I probably
understood.
wouldn't pass the physical. But nevertheless, I love flying aviation. I have no problems with it. To me,
I,
turbulence is like a joyride. You know, it's like a fun roller coaster ride for me. My wife sits here and basically welds, imprints into the seats, and
Uh,
I'm going like, yeah, that was a good one, Let's have a next bump, So I don't care, I mean, I love negative G's. It's fantastic, done
yeah,
acrobatics. So, but it's a bit of a way out there, so I would
it
just
is,
drive.
it is, but it's something you might consider in time. I understand that Michelle's got a lot of practice with driving now, so long distance driving is nothing to her.
yeah, I've done a lot of long trips. I had way back in college. It was not clear that engineering was going to work out, so I actually got a CDL a long time ago. That was a solid career choice, at least for me.
Really, did you do
Engineering,
that?
engineering worked out though, got a little better.
Well,
So,
I gotta tell you
but I can
that
still back up a trailer better than
I
almost
I
anybody else on
also
my block. So,
I also had a tractor trailer driver's license in New York State.
oh, very good.
And I gotta tell you how I got it. I got a tractor trailer license when I was in the Army at Fort Benning, Georgia. So I had a military license. And when I was transferred a few times, the last posting I was at was not that far from my hometown in southern New York State. And so I asked for permission to borrow a tractor trailer for a day to drive up to New City, New York to take my driver's test, my state driver's test. And they gave me one of these Vietnam era all-wheel drive tractors that goes off-road. I don't know if you remember
Yeah,
those,
I know what you're talking
with a 60-foot trailer. And I went to and I had in uniform because you can't drive it without a uniform.
about.
And so I go in, I take the written exam. They say, okay. And they assign me, the guy to give me my test. And he says, well, first I need to take your driver's license or your, learner's permit. And I said, I don't have a learner's permit. And he says, well, you need a co-driver to drive the truck home because you can't drive. I said, no, no, I don't need a co-driver. Here's my driver's license. It's a military license, and you can't take this. And he said, oh, this is, he didn't know what to do with that. So we just walked outside. He was going to get in, and we were going to go for a drive. And he took one look at that off-road tractor, and he signed
Yeah.
he didn't want to get in
Right.
it.
Yeah. Yeah,
He's
understand.
this is a
Right.
wartime tractor trailer. He looked at it and he said, "Okay, all right, I give
Hey,
up."
no,
He
you gotta,
signed it,
that's called a field promotion, Rick. That's a
and so I had that license for 20 years
very
until I
good.
moved to Maryland, and they didn't
Aw.
they wanted me to take tests over again. And I said, "Ah, the hell with it."
Yeah.
Uh, so you and I, we can drive tractor trailers.
Yeah, it's fun. It's neat.
Yeah, well,
Yeah, long trips are okay. They're, in moderation. It's tiring and all, not a
I
day.
hope you didn't need too big a truck to bring the lab
No,
back.
no, not at all. It was,
By the way, I felt bad for you because when I was president of AMSAT, I had to go from Maryland. Well, I had to send a team from Maryland to Orlando to gather up our lab there and bring it back to Maryland because a hurricane had hit and had demolished the building around our lab. It was on an airport, so it was a hangar.
yeah.
And our little section where our lab was okay, no damage. But the hangar was declared uninhabitable, so we had to get out. So I have some
Yeah.
experience in
No,
moving a
we
lab across country.
we had a very similar experience. This lab originally was in Florida, and the commercial site, it was a little teeny little factory with an office and climate controlled, and that's where this lab equipment originally was. And it was a hurricane that wrecked the building. Hurricane, and then when it was damaged and not occupied, a fire took out the rest. So that equipment had to be moved, and it was moved to Arkansas. That and then this particular adventure in providing open source lab for folks didn't quite work out. So now it's moved again. So let's hope you know uh, third time is a charm, and we'll be able to get a lot of good traction out of it. So very similar experience with our Florida lab, the original lab. It was the hurricanes are no joke, and the flooding and then the damage that comes after it takes a long time to recover. So that's exactly what happened to us with this lab in its very first instantiation.
Well, I'm rebuilding my website from scratch, my company's website, but attached to that website used to be, when I was back in Maryland 4 years ago, used to have personal websites attached to it, one of which was my call sign. And I've rebuilt most of that. I got all the pictures back finally, and not the captions, but the pictures. And among those pictures are a couple of galleries full of moving that lab.
Oh, very good. Oh, that's good stuff. You should publish that. I think that's a good article.
Well, it's the problem I'm having is I really would like all the captions back because they have all the names of
Yeah.
people, and I have the database with the captions, but I'm not sure how to activate the database again. I just have all the raw files, and I think I'm going to drop it into another Linux virtual machine, just copy those whole directories and see if I can get the database functioning enough so that I can start putting captions back in.
This is you're not alone with this problem.
But if you ever want to see those pictures, it's on gpstime.com/K0GD.
Okay.
I had one initial, another question regarding some of the radio reflection type of work as a sort of a modeling for an EVE type situation. Have you guys considered possibly? I realize tracking might be the problem with this idea, but there's a significant number of sort of fairly near Earth asteroids that fly by all the time. Would that not be possibly that way you could go maybe full power and then just try to with a small target like that and then utilize that as a reflection target
Sure.
for sort of some of these experiments.
Um,
I don't
I
know, the
don't,
tracking might be a little bit difficult with
oh,
the
no,
larger
tracking is not a
velocities.
problem for that. They don't move that fast. The one thing we cannot do with a dish this big is track low Earth orbit satellites very well. they're too fast for us.
Yeah. Okay. Yeah.
But
Sure.
asteroids, except when they're really, really close,
Yeah.
easy to track as long as we can get the Keplerians for
Yeah.
them.
Yeah, is
Uh,
that would that would be probably the biggest challenge is like nailing down the keps so that you can dial out the Doppler.
yeah, it shouldn't be very difficult. I think there's catalogs of those of the larger ones anyway.
Yeah, that sounds fun. I mean,
I hadn't heard that
we already
suggestion
talked about
before. That's a
EME,
good
right?
idea. Yeah.
Yeah, that's I think we
Just a thought.
I like it. No, that'd be cool. And I mean, we're already talking about EME, so you know,
Yeah,
maybe
well, that's a big target. So like you said, you have
yeah.
to work at a milliwatt off the moon. I kind of grinned and laughed at that. I just thought that's hilarious. But
Well, we
yeah,
can
I
ask,
can see.
yeah.
We should try to do a QRP challenge for EME, like put out a prize or something. Like
3 microwatts off the moon.
yeah, that would be kind of cool. Can you prove the lowest power EME signal? That would be a fun contest. That could be like,
Yeah,
hey,
I got bored with EME at our deep space site because you could
well,
take a cheap radio with a handheld microphone, pick it up, talk in it, and hear yourself come back like we're talking on Zoom. And I said, well, that's too easy. And that was only with our 300 watt amp. Now we got the 1500 watt amp.
no, with a big dish, there's certain things that are no trouble at all.
Well, I do recall stories of friends of mine climbing up into the feed of Arecibo and taking a 2 meter handheld with them and just standing there and talking off the moon,
That's
a
cool.
2 meter FM at 5 watts, when they weren't using it.
Wow.
Boy, you'd really have to time that one when the moon was in the Arecibo sort of pointing direction.
Yeah, yeah.
Wow. It's amazing.
And
Let's
then, of course, we have the Stanford ionospheric dish, which there's a duplicate of at Haystack in Massachusetts. They're both 300-foot dishes, um, which is a good bit bigger than ours. And you can do the same thing there. They're designed for 400 megahertz, so just take your HT with you and plug it into those dishes and point it at the moon, and your HT is all you need.
Yeah. There's another really big dish in Europe that we found out about through talking with Dwingelo and Stalker that might be amenable to working with us in 2026. It's like a 100-meter dish. It's enormous. You probably know
Oh,
the one I'm talking about. So
yeah, yeah. And we're working on the couple of dishes in Australia for the next
oh, good.
EVP.
There's some really good sites there. Yeah, I think that this can only grow. Like if we do the networking and and I'd
And
still
one of
like to
those
see like
dishes,
some sort of conference or some sort of meeting if somebody wants to host something uh
yeah,
closer to 2026, it would be a really nice event to have if we could possibly pull off an in-person workshop or conference to get everybody together in one place.
that'd be great, wouldn't it?
Be so good.
One of those dishes I was sort of surprised is in Tasmania. And the University of Tasmania has been ramping up their science and STEM programs and things because they often feel isolated from the main body of Australia. And it turns out that both parks and the Tasmania site are customers of mine. And I just shipped 3 more of my uh, GPS products to Tasmania a couple of weeks ago. And they sent me an email that said that they got there in good condition, which is nice to know because that's a long shipment. So I have products every now at radio telescopes from the South Pole station to Tasmania to Svalbard. So I pretty much covered everything.
Well, at least
And
that's at least four continents, right?
and I have a number of products up at the telescope in Hawaii, uh, and Russia, China, uh, Australia. and I get to know these people. After a while, you send a bunch of emails, and then you find out, oh, are we going to the technical operation workshop at Haystack this year? Oh, well, I'll see you there. So we actually get to meet a lot of these people. It's really cool.
Right on.
So I'm headed up to Haystack for that every 2-year workshop on the 3rd of May. So I realized that I didn't have my presentation finished. And so I worked on that yesterday and sent a copy to my partner at NASA for her review. And much to my chagrin, she said, well, I'm coming, but I'm in my 3rd trimester. I didn't know that she'd even gotten married to her boyfriend. Well, apparently she got more than married. So I'm not
Congratulations.
sure. Yeah,
Yeah,
I'm not sure
outstanding.
she's going to be happy standing there doing. I do the first and third thirds of the presentation, and she does the middle third. And I hope she's still still okay for the first week of May. It's cutting it awfully close
Right
to
on.
travel from Maryland up to Boston.
Special delivery. That's what
Oh dear.
right on. Yeah, congratulations in order for that. That's awesome news.
Well, she's a wonderful scientist.
But
Yeah.
in any case, I had another question on your lab setup, and that's regards to some of the Plutos that you have. And I think I might have discussed this with you guys at some point in the past. Has anyone tried to go in and sort of modify them to get better frequency stability out of the oscillators on those things, or locking them in externally to an external frequency or something along those lines? I have one that I don't want to tear into unless I see some kind of a protocol that seems fairly reliable to do that, because the frequency stability is noticeable if you're trying to listen to some of the narrow bandwidth stuff with them. But otherwise, they're great units. But I was just curious if anyone has tried to done any kind of mods to stabilize the frequency on those.
Yes, someone has. We have not done that here, though, so I can't give you any firsthand info. But there are definitely people out there who have put in a better oscillator. It's not a big deal. Um, it drops in. We have chosen instead to experiment with external oscillators. If you have the Rev C Pluto board or the Rev D, allegedly, but the Rev C is what I have experience with, then there's inputs and outputs for 10 megahertz reference clock. They're not populated, but they're on the board. So bringing them out, or maybe the connectors are populated, I guess, but they're not brought out to the outside of the case. So
Mine's a very early version. I don't. Is
yeah,
there was there a B model, or
there was a B. Yeah,
I think it might be a B. It's an earlier. I've had it now for quite a number of years when it first came out. So I don't know if those outputs are populated there or not.
yeah, they're not on the previous board revs.
Yeah.
We
Okay.
have a couple of those. That's why we have two setups on the bench right now. One with a pair of Rev Cs, so we can experiment with external oscillators and control the frequency error. And the other pair is, I think they're Rev Bs. Uh, but yeah, if you look on the web, you'll be able to find the people who replaced a oscillator with a better one and had good luck.
Well, my perception was that there was not a commercially available uh, drop-in that would have the tighter frequency stability. That you'd have to really do more extensive modification. I believe there was a guy even in Germany at one time that was selling a small PC board that had that you could modify them with, and he just kind of dropped out of providing those, and so I wasn't able to latch on to that. It was kind of during the COVID era, so the being able to get stuff in and out of Europe and back and forth was kind of a problem at the time I sort of contacted him. But in any case, so there's no way you guys would have like a part number or anything for that that was or at least a supplier that would have the clock that would drop in for it that has a tighter spec.
No, we'd be in the same situation of trying to search the web for it,
Okay,
as far as I know, unless you have some better info, Michelle. No.
just curious. Something that would be nice to be able to tighten it up, but. Yeah, I thought of that possibility of just trying to just rip it out and trying to feed in an external signal from
Yeah.
some kind of a GPS locked PLL or something. But
Yeah,
anyway,
that's like the cold air intake, man. It's like the first thing that you do to improve performance is to get your oscillator, good quality oscillator. That's for any digital mode with the Pluto. It leads directly to better performance. So it's the right question to ask as soon as you kind of get one. So there's a path forward definitely for essentially opening it up and putting in a better oscillator to actually soldering one in. And then if you can get a kind of a later model one, then the external option. That's what we're doing here, and that works pretty darn good. It's nice.
have you guys done the mod to bring them up to 6 GHz on any of those Plutos? The software where you can modify them so they can go up to 6 GHz.
No, we haven't needed to.
Okay,
We have.
Have we? Have we done that?
Yeah, it's just uh,
it's just a software
yeah, a
code,
setting,
yeah, a
basically.
setting, yeah.
Yeah, we have turned that on. It doesn't cause any problems within the normal range of frequencies.
So that was my next question. Does that frequency extension is it a significant drop in like sensitivity or frequency resolution or anything? Kind of stretching the that chip to go up that high. It's
Well,
not supposed to go up above, yeah, to that.
the chip is actually designed to go that high. It's just that the part they put into the Plutos is a bend part that hasn't been tested up that high. May not quite meet spec up that high,
I
but
see.
it works for the most part. You may get a little bit of degradation up the very tippy top, but it's not test equipment. It's just a radio. So
Right, right. Well,
Yeah, I don't think we've noticed any issues, you know. So not saying
we
that
haven't looked for them
try to
either.
do it, and yours turns out to be a grumpy part, that wasn't really intending to perform up there, then maybe it, but for the most part, I haven't heard a whole lot of complaints for doing this.
and on the earlier discussion, the Voyager sort of DSES attempts at trying to receive that. I was just curious the equipment that was being mentioned in terms of being able to pre-scale up to the 8 GHz band that I guess that they transmit on, and I was just curious if you had any information on that over from the SES site.
Yeah, we don't have that information available yet. That's a question I have for the European team because they've already done this, and I'm going to ask them what did they use for down converting to something less than 6 GHz where the SDR works. So they didn't put that in their presentation. They just said they did it.
Because I know there's a fairly active group that does a lot of the spacecraft signal reception in the 8 GHz band, and there's a quite active group. I think especially more in the European sector that a lot of people that are actually doing a lot of the Juno and Parker and all these other solar probes and so forth that they can report on the signal reception and in that 8 GHz band. So I was just curious what kind of up converters or whatever they might be using other than specialized front ends for that, since you mentioned it. But yeah, I was just curious.
Yeah, maybe we can try to track that down.
Should be pretty easy to figure out.
Yeah, there's some eight. I might even have some parts here from SBMS from like, annually they would have like a they call it a flea market, but it's for San Bernardino Microwave Society, there's all sorts of stuff, all the way up to like 47 gig or 80, 80 gig, 72 gig, that sort of thing. Might even have a few parts that purportedly go up to 8 GHz. So there's stuff that's available, but it's kind of bespoke or low volume. And then, I'm pretty sure like DV6NT has some on their commercial side of the catalog. That'd be the first place I would start looking if I was going to build a radio that wanted to do, 8 gig, cleanly or more efficiently. If not, then go find a 10 gigahertz station and then, sample it down, or, you know, that those are
Well,
the two big approaches.
well, not being a ham band, the 8 gigahertz for equipment, it's kind of hard to run across even surplus stuff or
It is.
secondhand. So that's why I was curious, maybe what kind of
Yeah,
source you guys are looking at.
yeah, at least for SBMS, this is all would be surplus, or, leftover parts from, you know, uh, maybe talk to JPL and see if they have anything in a box. Ever so often you find cool stuff like that.
So
You
if
know,
a dumpster dive off behind JPL, that's a thought.
that Courtney sent me, or
Great. Well, thank you very much. I just curious if you had any
yeah, no,
information on
well,
that.
yeah, I'll take
I
a question. I'll go see if there's anything that can be clapped together. Like if there's something out of, who knows, maybe mini circuits is like, oh yeah, here you go. Finding enough, well, this is on the receive side that we're really looking at. So,
right.
you
Yeah,
know,
right.
you don't really have to worry about the power problem, because at
No.
gig, that would be kind of a weird challenge, to find. But so yeah, let's see what we can find over the next week, in just maybe a literature search, to see what we can see, and that'll end up helping Rick out, if since they're serious about, trying to move into this and receive there, then every bit of research can help. So we'll see what we can find out over the next week. It'd be
Yeah, I've tried to sort of gather some equipment to put something together for that, and I actually was able to acquire an 8 gigahertz oscillator that can be externally 10 megahertz clocked with a GPS 10 gigahertz synchronized signal
oh yeah.
to stabilize it. And that seemed to work. I actually took it out to one of the local microwave group meetings, and they were able to hook that up to a frequency analyzer, and it seemed like it locked okay with a 10 megahertz signal.
Oh wow,
So
you're
that's at least the
way
local
ahead.
oscillator for it, but not
Yeah,
the rest of the front end. So it's just kind of building up to have the equipment for it. But in
still
any
no,
case,
that's like you're striding out ahead. That's a big achievement. That's good stuff. Okay, well we'll see if we can't catch up with you and
great. Sure. Well,
add to,
thanks.
no problem. All right. All
One
right.
other
Great.
Oh, go ahead, Paul.
one other little comment on the Pluto stabilization. Another choice is to buy a Pluto Plus. If you're not familiar with that, it's a
I've seen those on online. I'm just kind of a little bit leery about ordering anything from China right now.
yeah, you
I'm
can
not sure
also
what they'll charge me when
well,
it hits the customs.
that's a possible concern. I think there's an outfit called Ham Geek that sells them here domestically.
Oh,
They
really? Oh, okay.
they have stock.
I just ordered from Ham Geek a particular SDR, about $300, sort of an interesting SDR. And it ships from China. They don't have US stock. However, the the government has changed the duty so that it doesn't apply to electronics. So it's being delivered today for the same $300 I paid for it.
Oh, okay.
Good to know.
So,
And
so
and which
Ham
SCR
Geeks
is this?
looks okay.
Which SCR is this?
Uh, I forgot the name of it.
Oh,
It's
okay.
wait, I'll look it up here quickly. It's on Ham Geek. Here it is. It's the Ham Geek E310, 70 megahertz to 6 gigahertz SDR. It has the analog devices 9361 front end, which I like, and it has a Zinc 7020, which is not bad.
Oh, it's bigger than the one that's on the Pluto. What by one?
Yes, it's much better than Pluto, but not as good as a B210.
Yeah, that's true. Somewhere right in there.
But
That's a good performance. That's a good
For
design.
$300, that's not too
yeah,
bad.
299 plus shipping, which wasn't very much. and pay with PayPal. And it took a while to get here because I didn't pay for expedited shipping, but there's no evidence of any duties being charged on it. So
Okay.
either it's too inexpensive because there was a lower limit at one point on where they were going to charge duties, or it falls in the electronics. They're exempting cell phones and laptops and other electronics. So either way, all I'm saying is it's arriving today without duties.
Good deal. That's a good tip. Awesome. All
They
right.
also have Super Plutos for sale.
Super Plutos.
Yeah, Ham
I
Geek's a
know about
fun
the
little
Pluto
place to.
Plus. Is this like a Pluto Plus, but it's just a different name?
I don't know. Maybe that's what it is. Let's see. SDRs.
I know. Well, hey, it's a golden age for all of this. So,
Oh, here it is. It's a Pluto Plus.
okay,
Yeah.
cool.
Yeah,
Yeah.
$219.
I like Super Pluto though. That's fun.
Well, I've got an old Pluto and a new Pluto, and I went to try to buy those oscillators, and they had discontinued those TCXOs very early after the original article that said how to put the new one in. There's lots of other oscillators that can be used, but they don't fit. So you're going to have to adapt them
Yeah.
somehow.
That's what I had understood. Yeah.
Good to know.
Oh, well, too bad.
All right. Well, any last comments or questions before we close for the day? All right. Well, thank you, everybody. This is really fantastic to have all these wonderful conversations and hear about all the projects, and so honor and a privilege to be able to share the work with you all. And we'll look forward to over the next week finding out all the cool stuff and all these action items that we have. And then we'll be back next week, if not before. So just keep an eye on Slack and see if there's any other meetings. If anybody has any questions, then please reach out. And just thank you again for
Did-
being part of this. It's a big adventure.
I'm not as I haven't been able to find your Slack site. Do you have like a link for that or an invitation, I guess is what it is for Slack or
Yeah, the information's at the Getting Started page.
Oh, okay.
We have a
Okay.
Getting
I'll
Started
look there.
on our homepage, and then it'll tell you the email address to write to get it put on the Slack. But yeah, everybody's welcome there. We have lots of different channels for different projects and different areas, and then that's sort of the daily conversation happens there. So yes, so yeah. And failing that, you can just get in touch with me and let me know your preferred email address, and then and that you want to be added to the Slack, and I'll take care of that. So either way. Yeah, groovy, everybody. All right, see you next week, if not before. And yeah, looking forward to all the things we've talked about. Getting a little bit closer every week. It's good stuff. All right, everyone, stay safe for the week.